Good morning. Happy Monday to you. Welcome back to Advanced Topics. This is going to be the first of many short lecture videos, so that way I can get this content to you in many different forms, so make it easier for you to learn since we can't be in the classroom together. All right, so today we're going to start off our new unit on probability. All right, no more graphing. Yay, I know you guys are very excited about that. All right, so this section is a little bit more interesting, plenty of real world examples that we're going to talk about, but we're going to start off simple, and then of course, like always, it'll get a little bit more complicated as we move forward. Make sure that you go in and take a look at the PowerPoint notes that I posted for the entire section. All right, so let's get started. All right, so this first section is based on what's called counting concepts. All right, so we need to learn this concept before we move into the actual probability portion, which we'll talk about in later sections. But this is section 1 of the PowerPoint. If you want to kind of follow along, you can. All right, so we're going to start off talking about something called the fundamental counting principle. All right, and so basically what this says is that anytime that you have a set or a group of items, all right, that you want to either arrange in a certain order or you want to group them together, all right, this is how you determine how many different ways you can accomplish that. So let's start off with the most basic of examples. Let's say that we want to arrange letters in the alphabet, okay? So let's say we've got the first 3 letters of the alphabet, all right, A, B, and C, okay? And I want to say how many different ways can I put these letters in order without repeating any of the letters, okay? So let's go through and just do that manually. So I've got 1 here, obviously, A, B, C. All right, so that's one way, okay? Next way, we can switch the B and C around, and I can do A, C, B, okay? All right, third way, I can put the B first, and then I can do A and C. All right, fourth way, B is still first, and then I can switch the C and the A. Fifth way, now I can put C first and do A and B, or I can do C first, then B and A. Okay, so there's the 6 different ways that I can put these 3 letters in order without repeating any of the letters. Okay, so the fundamental counting principle says that based on how many items that you have to choose from, all right, is going to determine how you fill each slot. Okay, so we notice we have 6 here. All right, so let's say we wanted to put these into spaces here. All right, so if I've got 3 available spaces to put these letters in, and I can only obviously put 1 letter in each space, all right, then in the first space here, how many letters do I have to choose from? Well, I've got A, I've got B, and I've got C. So I've got 3 different letters to choose from. So I have 3 options to put in that first available slot, right? Now, once I choose a letter, it doesn't matter which letter it is, all right? Now I need to go on and fill the second slot, okay? Now, since I can't repeat any of the letters, one of the letters is here. Now, how many choices do I have to put in the second slot? Well, now I only have 2 choices, right? So let's say I put A there. Now I can either put B here or I can put C there, all right? So I have 2 different choices to fill that second spot. All right. Now, once that final spot or that second spot is filled, now I need to fill the final spot. All right. So now I've put 1 letter there and 1 letter there. So how many choices do I have to fill that last spot? Well, there's only 1 letter left. So that means I have 1 option there. Okay. So the fundamental counting principle says if you take those values and you multiply them all together, then that will calculate how many different ways that you can arrange those items in that group. All right, so in this case I would do 3 times 2 times 1, and my total combinations or arrangements would be equal to 6, all right, which is what we came up with when we did it by hand, okay? So what do we notice about this equation here? So what's that called when we take a number and then we multiply it by each integer all the way down to 1? Well, that's known as factorial, right? So remember, factorial is represented with a exclamation point. So this could also be written as 3 factorial, which is also equal to 6. So if you've got a group of items and you want to say how many different ways can I arrange them, you're going to simply take the total number of items that you're arranging, and you're going to take the factorial of that number, and that will give you the total number of arrangements that you can make. Right? So for example, let's say I wanted to say how many different ways can I arrange the first 5 letters in the alphabet. Okay, so let's say I have A, B, C, D, and E, and I want to say how many different ways can I arrange those? Well, I probably don't want to sit there and do this because it's going to be a lot more than 6. All right, so the fast way is say, okay, I've got 5. All right, so I've got 5 slots available to fill. So how many choices do I have for the first slot? I have 5. Once I fill that slot, now I have 4 letters to choose from. Then I have 3, then I have 2, then I have 1. So multiply all those together, aka 5 factorial. So 5 times 4 times 3 times 2 times 1. And so there's actually 120 different ways that I can arrange those 5 items, all right, which is 5 factorial. So obviously that would take a while for me to list that out by hand. So this fundamental counting principle is a quick way to calculate that. All right, so let's take a look at another example here. Okay, so let's say we have 6 pictures that we want to hang on the wall. All right, so we're going to use these little colored cubes here to represent these 6 different pictures that we want to hang on that wall. Okay, so we want to hang them in a row, either horizontally or vertically. We want to figure out how many different combinations can we set up with these 6 pictures. And obviously we can only use each picture once, and we're just going to put them in an order. So anytime that you have a problem to where that you're trying to arrange things, like put them in a specific order, the entire group or even part of the group, all right, you're going to do the same concept here. So I have 6 pictures. I want to hang all 6 pictures, all right? So then I'm going to have 6 slots on the wall to fill. Okay, so same concept. All right, the first slot, all right, how many pictures do I have to choose from? Well, I've got 6 different pictures that I can put in that first position there, okay? And then once I place that one picture, now I only have 5 pictures left to choose from, so I've got 5 choices for that next slot, and then 4 and 3 and so on, all right? So once I've got that set up, then again, I'm going to multiply that together. That's the same as saying 6 factorial. So how many different ways can I arrange these 6 pictures on the wall is going to be 6 factorial, which is equal to 720 different ways. So obviously you'd be there a little while trying to organize those in that many different ways, all right? So you can also do it with only a portion of the group. Okay, so let's say that I only want to hang 3 of these pictures up, but I have 6 to choose from, and I want to choose the 3 best in order to decorate my wall. All right, but I've got 6 pretty good pictures. All right, so let's say that I want to arrange them in a row. All right, how many different ways can I fill this first slot? Well, I still have 6 pictures to choose from. Okay, so that means that in this first position, I can put one of those 6, all right? Once one of those is placed, okay, now how many pictures do I have to choose from to fill that second slot? Well, now I've got 5 pictures, okay? So 5 goes there. And then in the last slot, I've got 4 left to choose from, so that 4 goes there, okay? So I've chosen the 3 best pictures for these 3 spots. I've only got room for three pictures out of the 6, all right? Same concept applies, except I'm only going to be filling those 3 spots. So once I have those spots filled, I'm still going to multiply these 3 numbers together, but I'm not going to go all the way down to 1. So it's not going to be 6 factorial in this case. It's simply going to be 6 times 5 times 4. All right, so this is what we're going to use in order to find this group and how many different ways that I can organize just those 3 pictures. So I'm going to do 6 times 5, which is 30, and then 30 times 4 in this case would be 120. So if I'm only putting 3 of the 6 pictures up, how many different ways can I organize 3 out of the 6? The answer would be 120. All right, so let's take a look at a couple other real-world examples to where that we're not talking about the one set of items, all right, or the same group of items, okay? So let's say, for example, you are trying to pick out a great outfit to wear on a date that you got this weekend, all right? So obviously we want to look good for whoever we're going out with, all right? So let's say that in our closet, all right, we have 4 tops to choose from, okay? And then those will match up with 3 different bottoms. So we'll say shorts or skirt or whatever, or jeans, all right? We'll say jeans, all right? We'll keep it universal here for guys and girls, all right? And then we really love our shoes. So let's say we've got 6 pairs of shoes to choose from that will match up with those shirts and jeans, okay? So we want to choose the best outfit that we can out of these choices here. So we would say how many different ways or how many different combinations can we put together with these matching sets, all right? Maybe you're trying to pick out your clothes for the week or for the month. You say, how many, with these sets of clothes, how many different ways can I combine them, all right? So I've got 3 slots to fill, right? I need a top, okay? I need jeans or a bottom. And then, of course, I got to have shoes, right? So those are my 3 slots that I need to fill, all right? So we're going to use the same concept that we used before, all right? Except we have different groups to choose from, all right? So out of the tops groups, all right, we can't put jeans in the top slot, all right? So we're not choosing from the total pieces of clothing we have here, which is 13. We're only choosing for the one that can fill that slot, and right here, that's a top. So how many tops do we have? Well, we've got 4 of those. So we've got 4 possibilities to choose a top, all right? Jeans, all right, we've got 3 of those. So we've got 3 options for jeans, and then we've got 6 pairs of shoes. So we're gonna put a 6 in that last slot, all right? So how do we figure out the math? Well, it's the same concept. We're gonna multiply those 3 values together, okay? So remember, they don't have to be sequential like they were before, depending on how many are in each group, but we can only choose from each group, all right? So in this case, I'm gonna do 4 times 3 times 6, so 4 times 3 is 12, and 12 times 6 is equal to 72. So I can put together 72 different outfit combinations based on those 4 tops, 3 jeans, and 6 shoes. All right, so you guys thought you needed a whole huge closet full of countless clothes, but you really only need a few items there, and you can make plenty of cool combinations. All right, so let's take a look at one more real world example, something a little bit more current. All right, so I know we're all quarantined into our homes, and there's not really a whole lot to do, so I'm not really worried about picking out outfits right now. We're pretty content in our PJ bottoms and our hoodie and our flip-flops or our slides. So we're not gonna worry about clothes right now, but what we gotta do is we gotta eat, right? And so obviously we get bored with eating the same old thing, so we go to the fridge for lunch and we wanna figure out what we're gonna do to make sure that we don't get bored with eating the same thing every day. We're gonna take a look at how many different options we can choose from based on what's on the fridge, okay? Or what's in the fridge, I should say. So let's say that we wanna have a main item, All right, a side item, so maybe something healthy, and then a drink. And we say, how many different lunch combinations can we make? All right, so let's say we go to the fridge and we open it up and take a look at what we've got for main items. So for main items, all right, for lunch, we could do a good old-fashioned PBJ. All right, who doesn't love PBJ? All right, we've got some ramen noodles that we can cook up. All right, we've got some leftover chicken from the dinner last night. All right, and then we've got some mac and cheese. Okay, so that'll be our main item. All right, so we've got a total of 4 main items that we can choose from there. All right, for our side, all right, we can have some chips. We've got some Doritos or something in there that we can throw on there. If we want to go a little healthy, we've got an apple. All right, or we've got some baby carrots we can eat. Okay, if you want to go the vegetable route. Okay, so there's for our side item. So we've got 3 sides that we can choose from. And then, of course, we need something to drink, right? So let's say that, we can do water. All right, we can have milk. All right, there's some soda in there. All right, and some juice to choose from. And so those are our choices for our drinks. All right, so we've got 4 choices for a drink. All right, so we want to say how many different lunch combinations can we make with those options. So if you go into the kitchen, you're like, oh man, there's nothing to eat. All right, this will maybe help you decide on what to put together. All right, so if I want to figure out how many different lunch combinations I can make, well, then I'm going to take the total number from each category. I need to fill those 3 spots. So I need a main course. I've got 4 choices there. I need a side item. I've got 3 choices there. And I need a drink. And I've got 4 choices there. So if I multiply those 3 together from each category, so 4 times 3 is 12. And then 12 times 4 is 48. Okay, so that gives me 48 possible combinations that I can put together for lunch each day. So that should keep you pretty busy, even though you're locked up and can't go to the store. All right, so hopefully that'll help you understand counting concepts and the fundamental counting principle. All right, take a look at some of the examples in the PowerPoint, and tomorrow we'll talk about 2 specific types of counting concepts: permutations and combinations. All right, don't forget to go and check out Khan Academy and try some of those assignments, and we'll talk to you tomorrow. Have a great day.